Hello everyone, welcome to this video. And in this video, I'm going to discuss how to get the Cronbach's alpha's value in tree method. So when we look at Cronbach's alpha, it goes with the internal consistency of an instrument or a material that uses that you're using either in your research for educators when you're seeing now the internal consistency of the exam that you're using. Okay, here's the first method on how to compute now. What I call this, Cronbach alpha. So in computing Cronbach alpha, it will see your internal consistency or reliability of your test. So the first method that I'm going to use is what we call using the variance. So I have here, let me just explain our data. Let me just make it a little bit bigger. So we have now question 1, question 2, question 3, question 4, question 5, question 6, and then respondent 1 to respondent 8. So I'm going to get now the variance of each question. So I'll denote that as var or variance. So I'm using now the sample variance of var that is, or you can primarily use var and then selecting from the first going to the 8. And then I'm going to drag it going here. So I'm using now 2 decimal places. So that is now our variance. Now, next thing to get now is the total of each respondent. So as you can see, you can get now the total of this one. Oops, sorry. I forgot to write this. I forgot to type now sum. And then from here, going to the sixth. So as you can see, we have now this one. Okay. Now, we also need to get the variance of this part. So we got now 13. Wait, 13. Now, as you can see, let me just divide my screen into 2. So you can see this one. So I have here this one. So I'm using now Cronbach's alpha variance. So as you can see, the formula is alpha is equal to k, which is the number of questions, and then k minus 1, then multiply to the variance of the total minus the sum of the variances over the variance of the total. So as you can see, these are now the denotation. So we have now our data. Let's look at now our data. Let's use now our data and using now Excel. Now, as you can see, at k is that we're using k is 6, so denoted that, so we could have that. Then k minus 1, that is 5, so 6 minus 5. And then let's go with the summation of sum of variances. Okay, let me have that. So we can have sum of variances. So how are you going to go with that? Sum, open. So let's go now to the variances from the first question going to the sixth question. So we have now the answer. So let me have this one so that it will be on a very good setup so that you can see that. And then let me have that again. Okay. So we have now from question 1 2, and then we got now the variance of the total score. So variance of total. So let me just denote that. So we have now 13.13. So we have now all the data that we need. So we can now compute this. Oops, let me have this one. So 2 decimal places. So I think we can have that. So let me just use this one. So let me just copy our formula so that I can do that computation here. So for a while. So this is now. So we're getting now the alpha. So k, so we denote that as 6, and then 6 minus 5, 6 minus 1, it's 5. Substituting that so that it's much easier. So 13.13, and then this would lead us to, this is 13.13 as well, and then this is 5.98. Now let me use this one, copying this one so that it will be on the process. However, I'm going to use Excel as well. So in the process, as you can see, 6 minus 1 is 5. So that you can see that. And then 13 minus 5.98. So let me have that. So difference. So let me just get the difference. So it will be denoted here, difference. So 13.13 minus 5.98. Oops, let me have that again. So there's no dot. Okay, that's 7.15. So let me type 7.15 and then 13.13. So let's have now the division. So let me have that. writing that alpha. So, oops. Okay. So I believe I have here dividing k minus 1, dividing 6 by 5, that would be around 1.2 if I'm mistaken. 6 divided by 5, that's 1.2 or 1.20 using our 2 decimal places. 1.20, and then 715 divided by 13. So I have there the quotient divided by the 13.13, so 0.54. 2 decimal places, I'm just going to use now 0.54, right? Then getting now the product, we have now the product of that, so we'll get now our answer. So product of this one, 1.20 times 0.54, that would be 0.65. So that is now our Cronbach alpha. We'll have the interpretation later. So that's the first method, Cronbach alpha using variances. Now, let's go now to the second method. So let me just maximize again my screen. So same data, so what we get is 0.65. So this is now our Cronbach alpha. So I have the data, I have the file as well. So let me just get this one and create a new sheet. So here, in this part, let me have this one so that it will be smaller in screen. Okay, now what I'm going to do is I'm going to get now the correlation of each question. So we're going to get the internal consistency of question 1 to question 6. So getting now data analysis. If you haven't don't have this part, you can activate this one. I have a video on how to activate data analysis in Excel. So you can search that on my channel. So correlation, click that. So selecting from question 1 to question 6, and then all the data, make sure to put the labels on. And then I'm going to put now the answers here. So getting in that, so you have now the correlation for a while. So that's now the correlation. However, I want to make this one in 2 decimal places. So that's much clearer and concise. Now, so let me have my second solution. So working on that. So let me have this one. So using now Cronbach's correlation, we're going to use all the correlations that we do have. The one, you'll not include the one because that is the correlation of itself. So you're not going to include that. It just so happens it shows that question 1, the relationship to question 1, relationship to question 1 is perfect, positive. So now, using now the correlation, there's now what we call the standardized Cronbach alpha. I just gonna search this one, this formula. So let's look at now. The k is the number of questions, so we have 6 again. So let's look at that. So we can put it here. K is 6, right? And then k minus 1 is 5. Then our AVE or RAV, I'm saying, is the average of the correlation. So let's get down the average. Average of the correlation, starting from this one, from 6 to, comma. You're not going to include the 1 because that's not a correlation of itself. That's a correlation of itself. So I'm not including that. Okay. Getting the correlation. And then on the last one here. So that is now the average, or 0.24. It might have this an error because we did include the 1, but if you erase that, it will be removed. So we got 0.24, right? Now, we can now compute it here. So using this formula, once again, we're computing now for the standardized Cronbach alpha. So it's just the same. So when we set that up on a manual process, so let's have this one, we get now the alpha. We have alpha. Okay, let me just put it at equal, that will be k is 6, right? 6 times 0.24 multiply all over 1 plus k minus 1, that's 5 times 0.24. So let's have now the calculation using Excel. Let me have that. So first one is 6 times 0.24. 6 times this one, 0.24. That's 1.45. Let me have that 2 decimal places for this one, for this column. So that's much easier for us to look at that. Missing 2 decimal places, but however, it depends upon the other, on your standard in your school. So 0.5 and 0 times 0.24, that's 1.21. Then adding now 1, so 1 plus 1.21, 2.21. So I can now divide that. 1.45 divided by 2.21, and the answer is 0.66. So there's a difference from using the variances. So as you can see, let's have this one. So when I type that, so I completed that 6.24, that's 1.45. Then 1 plus 5 times 0.25, that's 2.21. That I'm going to process that so that you'll have a copy of this one. So as you can see, the processes. So alpha would be equal to 1.45 divided by 2.21. It's much easier if you're using Excel. And then you have this one, alpha. Let me get the alpha again. That will be equal to 0.66 or just closely to 0.65. Okay. Now the third method, so that's now 0.66 or 0.65. So two methods are almost the same. However, let's look at now on the third method. The third method is that we're using now ANOVA. Okay. Let me copy again the data that we do have. Actually, I can use it here. Okay. Now, what we're going to use is, let's go with data analysis. So just watch this one, and then you use now ANOVA two-factor without replication. So you select now that, however, you select the numbers only, no headings, because it's replicating anything. It's you if you use check me labels, because you are looking at the two factors, so it will look at the columns and the rows. Okay. Now next, you can put that on a new worksheet. So let me just click that so that I can explain it. So this is now the data, the ANOVA two-factor without replication. Actually, this is the thing that they compute. This is now the averages per row, and then this is per column. Now, as you can see, what we're going to use there are two numbers here at the ANOVA analysis. We use now the error. This one, the error, the 0.75, and then the 2.18. Okay, now what we're going to do is that 1 minus, open parenthesis, the 0.75 divided by 2.1875. And then close parenthesis, and this is now what we got as our Cronbach alpha. So all the data are just the same, right? As you can see. So let me just look at that on the two decimal places. That's all 0.65. However, what are we going to do? Is it really going to look at now how to interpret now Cronbach alpha for internal consistency? Now, we can use the internet for that. So I'm just opening now on Microsoft Edge. Let's look at that. So it's opening now a browser so that we will see now our computation. So what is the 0.65 mean? So look at now this one, Cronbach's alpha interpretation. So we're looking at that. So as you can see, it's still searching right now. So as you can see, on an image, you can use something like this one. If you're going to use this one, the rule of thumb, the internal consistency, as you can see in this image, there are a lot of standards. It depends upon what you're going to work on. However, if there's a thing that you're going to use, under the statistics show2.com, okay, the image is not working. However, let's see this one. Let's go in images. Okay, as you can see, it's excellent if it's the alpha is greater than between 0.9. Let me have that. It's not working here, but let me just put it here on the images so that you can see. So the more reliable, so it depends upon the standard. However, we can use this one to favor our paper. It's if it's between 0.6 to 0.80, it's reliable. However, if this is the thing that we're going to use, we're going to have a questionable standard. However, it depends upon the standards on your institution or in your school, what you're going to use. So that's how Cronbach alpha works. That is how you get now Cronbach's alpha. I hope you could use this video to guide you on how to compute your Cronbach's alpha. If you have any question, comment down below, and I hope I could answer those questions. Thank you very much for watching. Have a great day.